Um, it's 6 p.m. Central European time. Welcome, everybody. We're just going to start on time. If anybody misses anything, the video is going to be uploaded to YouTube. If you cannot hear me, please make yourself noticed in the chat. That's also the only way to interact with me. I try to keep an eye on the chat window, but I like to get excited when I give these meetups, and anyway, I might miss it. But I will definitely come back and catch up with you. Okay. This is part 2 of the cluster administration guide. I'm going to do the following. I'm going to just take a couple of minutes to review a little bit what we had last time, effectively, a little bit of the anatomy and the start of the cluster, just to pick you up where we left off last time. If we don't get through the entire agenda during this session, it doesn't really matter, because we're going to keep on making the parts as we go until we're done with everything that is there to know about the administration hands-on. So this slide will be the last slide that you see. I'm going to exit the presentation. Apart from that, it's really annoying to work with Zoom, apparently on a Mac, as I don't see my mouse at all. Right, that's it. We're going to do a couple of things. We're going to do let's just start off with creating a cluster real quick. I have built a small set of machines. It's consisting of 5 computers. I'm going to just start off with creating a cluster as I go. I have typed in these commands already, so let me just repeat them. The machines are C9 through C13. I'm going to start with C10 through C13. We're going to add the C9 machine later on. And as far as I remember, the last time when we were doing these things, we did not use authenticated communication between the nodes. So this is going to add a tiny little of complexity, which I would like to also go over a little bit. But really, it's once you know how to deal with it, it's really simple to do. The good side is that even if you're inside a SSL setup or so, there is no way that any malicious software would be able to interact with the ArangoDB processes within each other. So if you could somehow break into that network, you still wouldn't be able to communicate with the servers. Anyway, let's get this started. I'm fairly certain that I have already deleted the directories. Let me see. Yeah. Let me do the join. This is the same command everywhere. This is C12. Let me do the join here too. Am I in the right directory? Yes. And as soon as I got 3 servers together, do you remember from last time, the cluster will be started. Let me go ahead and do another join here. And so we have already 10, we have 11, we have 12, we have 13. And we should already have a cluster going at this address. I'm going to make the screen a little bigger. Once you have an authenticated cluster, you have to also log in. There is no way to access the cluster without. But as the cluster was just set up, there is no root password. The root password you can change within the user's part here. I'm going to leave that for sake of simplicity for now. For my own sake of simplicity. We're going to wait for the dashboard to start picking up the initial data, which it has done. We can have a look at the way the nodes are set up. Yeah, maybe I should, let's go back quickly here. What did I do? I just took the starter, the ArangoDB starter. This is the program that is coming with every installation of ArangoDB. And it is In contrast to the ArangoDB daemon, the one that just ends on a D, it is a means to really deploy these deployments in an easy way. So this would be an easy deployment that you could do. Oh, I have an issue here with power. I'm terribly sorry. There's an issue with the cable. If I don't fix it right now, we will not be able to continue. I'm sorry, I'm gonna be gone for a minute. Okay, situation saved. Sorry for that. Had to run across the office. Yeah, so let's. So this ArangoDB program is really there to allow one to deploy a cluster easily. It is starting all the processes that are necessary in the backend. Yeah, so let's go back here and review. We have 4 servers. They are on these machines you just saw. The whole thing is now an authenticated cluster, which means that the only way to interact with the nodes would be either through the coordinators with username and password, or to any other node, including the coordinators, using the JWT secret that you just saw as part of these commands here. So we're just specifying this secret. The secret in this case is just ABC. If you care to look, that's what it is. But it also does the following. If I now try to directly say access actually that's not true, C11 8531 API agency config, to just check what the configuration of the agency looks like, I wouldn't see anything. I have to add some additional stuff. In this case, authorization, there JWT again, minus A, HS256. Don't worry about the commands. They are all going to be in a separate document that I will upload with a video. Minus secret ABC, minus S, server ID is setup. Minus S, ISS is ArangoDB. Oops. Yep. Somebody typed in too many S's. This is C and this is C. Okay, so this is necessary. The only thing that I added, and I think I had it as part of the commands of last session, is that I had to call this command. In order to get to this command, you will have to install nodejs, and afterwards you will need to install this JWT command. Right. What we know right now is that the leading agent, which won the election in the first term, this is a Raft consensus protocol, it's also part of the first session. I will not get into too much detail right now, but anyway, the agent that is leading the agency right now is the agent with this ID, and if you check, this is going to be agent C12, so if you wanted to effectively get anything from the agency, that's the place to go. And for example, we can look at all the jobs that have finished that have been run and finished. There are no jobs that were run, so we expect an empty document in this case. And let me go and get Arango. I think first of all it's 0 Arango target. So target in the agency. Let's go into some detail in what you will find in the agency. This is not something that we talked about last time. Target in the agency has a couple of key parts, which is this finished bit here, and there is 3 more down here: pending, to do, and failed. This is where everything that the supervision in the agency, which is monitoring all the cluster nodes, will be guarding, using to store all the jobs that are running, have run, failed, finished, and vice versa. The ones that are still to be done, they end in to do. The ones that are running right now would be in pending. The ones that failed, obviously, in the failed part, and the ones that are finished would be in finished. And we will see a couple of those in a moment, because we're going to intentionally break things. We are going to remove hardware from the agent, from the cluster, and add new hardware into it. Yeah, so this is effectively also holding a couple more information. These are the coordinators that you see here with their short names. So if you go to the front end and you see all these nice short names, that's where they are looked up. And yeah, let's go ahead and create a database. Currently, the only databases that are here, they're found in Arango, for example, plan and databases is the system database. It has, this is the one database that's always going to be there when you start, regardless in a cluster or a single instance. And let's play a little bit with doing stuff in a different database, because it's going to have a little fewer collections than the system database. It's easier to find things and vice versa. Let's create a collection with 9 shards and say 3 replication factor. Shouldn't take too long, okay. Oh, I'm here wrong. Let's remove this guy again, delete. We did not change the database. Let's go here. What happened to my database? I never created one. I created a collection. Okay, let's wait for the database to appear, and then we can switch into that database. Okay, now we can go to foo. Come on. Right, we are going to create a collection here. Let's call it bar. It's going to have 9 shards and 3 replica per shard. Disappears really quickly. We go back and check and see that we have the shard, we have the collection with 9 shards, which are replicated 3 times. If you look across the way the cluster has distributed them, it's fairly random. That is, that if you look through, you will find that every DB server is somehow leading a shard, every DB server is a couple times following other DB servers as replica. And what you should also notice is that they are fairly random and all over the place. So all DB servers 1, 2, 3, 4 seem to have some responsibility here. 431, 243, 342, and vice versa. Let's go ahead and just kill the last node that we started, the one that doesn't have an agent installed. The reason why I'm going to start with that is because this is the simplest case. Now imagine that you have a cluster set up with multiple machines. It doesn't matter how many, let's say 15 or whatever, or in this case 4. And you would like to get to replace a node, for example, or nodes completely crashed, the hard disk is gone. This is in complete disaster recovery in a way. Let's just go ahead and, as you can see, as I just showed you, we have all the DB servers somehow involved. Let's just go ahead and take the one that never had an agent on it. This seems to be not one, because as you can see, it said that it started an agent here. This has got an agent, we don't want this. This here's got an agent, we don't want this, but this one doesn't have an agent started. So let's just stop this thing here, right where it is. It will also exit fairly quickly, and if we change into the UI, we already have failed nodes. Now this bogus, this number up here is bogus. What happened here? Oh, we killed a couple. What is this? What is going on? Ooh. Oh, that was a glitch. Good. Maybe a browser cache thing or something. I was playing with this earlier, as you can imagine. I did not come here unprepared. So, okay, we got 2 nodes that are failing right now. It's a coordinator and a DB server. In terms of ArangoDB, these are instances. This could be located on the same server or located different places. But let's go and see the consequences of this when we go to the shard overview. As you can remember, we used to have DB server 0004 involved in all of these shards, or in most of them at least. It's been completely relieved of its responsibilities, and when you go back to the commands that I was running earlier, where we were looking at this target thing here, see there are no pending jobs, there are no jobs to be done, there are no failed jobs, that's good, but if you scroll higher up, we see that a couple of things have happened in the meantime. Let's see, this is job 12, job 14, where's the beginning of this all? Here's job 12. It's a failed server job, and it had consequences because the failed DB server here was responsible for multiple shards. Let's see what happened. For example, there's a job 12.1, which replaced the follower. This DB server was replaced with this DB server following the shard, this shard here. And let's look a little further. We should also have failed leaders. For example, this one, where this shard has a new leader now. The new leader is this one. We started with a DB server that just failed. Again, let's have a look at the command. Really just discard this bit here because this is just the authorization part. We are just reading anything that is in the agency. This is the read API. I hope you still remember. You probably don't, but anyway. And then if you look further into the JSON using JQ is a really nice tool that I use a lot to parse and traverse JSON files with by accessing directly elements and vice versa. It's very, very nice. That's where it's located. So in Arango target, you will find all these things. And we should also, if you care, you should also be able, so in case you want to write your own monitoring of ArangoDB, if you look at the supervision key, so this one here, you see that there should be a failed DB server here. And if you look a little further, we should also find a failed coordinator. Here it is. This is the failed coordinator. We also see that apparently, evidently, I mean, this was not a big surprise, that both are going to be on the one machine that we just stopped, on the one with the IP ending on 13, and the other one should also have the one with the IP ending on 13. Where is it? Here it is. Okay. This is fine and good, and it doesn't mean that So we can easily recover from a situation like this because we don't have any shards that are not fulfilled replication factors. Let's go ahead and break another machine. Now, the next one that I'm going to break is going to have an agent on it. And this is where things get a little trickier. By the way, if we wanted to just restart this one, let's just do that for the fun of it. Let's just go ahead and start. Where did we stop? Here it is. Let's just start this guy, and it will just show up, and everything's going to be fine. Maybe you just rebooted the machine, and there it is. It's back. Now it had an adverse effect. So if you just wanted to reboot the machine because you upgraded the operating system or vice versa, and it just needed a reboot. It's all fine and good, but there is a key thing that is that should be kept in mind. As you saw just now, it has consequences. That is, the agency and the supervision in the agency will start shifting shards around pretty directly. The reason why we don't wait for long is because it can be it could happen that another problem arises, and if you have too many failures, obviously, you will not be able to recover from them. Once the only replica of a shard is gone by multiple failures, your service will stop operating. Okay, so let's turn this off again as we intended, and because I want to get to a situation where we are really not fulfilling the replication factor any longer. Let's just check which agent is leading. I think it was C12 as far as I remember. Yeah, it's C12, and we can also go back. This is, by the way, the only agent that will respond to read and write requests. Every other agent will redirect you here, but if you have authorization turned on, curl doesn't retry the authorization. This is a safety measure. Obviously, you don't want to transmit too much information into some bogus machine on the network. So let's just remove all this. Let's just take the config. Oops, what happened now? Yeah, I can't do this anymore because now the document looks differently. Okay, so C12 is the agent with ID 76 blah, blah, blah. This is down here. And you also see that it's still communicating with both its followers, this agent and this agent. Last time when we called this command, it had just communicated with them a 10th of a second ago, 13th of a second ago, 14th of a second ago. Sorry, 1400ths of a second ago. Right. Let's just go ahead and kill that one. C12, where is C12? Let's find the guy. This is C10, C11, C12, and just stop it. It will take a little longer. Why will it take a little longer? Because the first thing that needs to happen is that the other two agents, let's go back and see if they have already managed to re-elect a new leader. They should already have re-elected a new leader. Let's ask one of them that is still there. Yeah. And it seems to be 8DC8. 8DC8 is the guy on 10. If we go here, we also can see the effect of one of the agents being down now. The former leader is down now, hasn't communicated with the leader for 38 seconds now. So the first thing that needed to happen was the agency needed to re-elect a new leader. That takes a couple of seconds. And after that is done, the leader will not immediately start taking action. So if it realizes that the DB server is missing here, it doesn't send me the heartbeats and so on, it doesn't immediately start doing stuff. because it's well possible that whatever brought about the situation that you had a re-election of a leader might also be the reason why you haven't had a heartbeat from some DB servers, one DB server, whatever. The thing is that it's a good idea to just wait a couple of seconds for things to settle down and then realize, okay, this missing DB server is really missing, I'm gonna take action. Okay, so let's go back and see what's happened in the meantime. Now everything's gone red. We are now, everybody who are missing is, altogether is 4 nodes that are missing. If we go to our shards and look here, we see that there are followers missing and leaders are now only 1 and 2. Okay, so what happened in the back end? Let's go back, check with the jobs again. It was retarget, remember? Now I can't ask C12, can I? I can just run this. It will not respond because we shut down that server. So I have to go, let's go just to the one that we know is the leader and look at the target again. So this is the first time that you guys see things sitting in to-do and a job sitting in pending. So what is going on here? This is a failed server job. Okay, so the supervisions realize that this DB server is missing. As a consequence, it found out that it's been follower and leader of some shards, but the failed leaders it can satisfy, or actually has to do something about them for the operations to continue, because the leaders of shards will only answer requests when they come to the coordinators. So those have to be handled. But the thing is that we know that we have in-sync followers, so we can immediately shift the responsibility of a leadership from the old leader that doesn't respond anymore to a follower that had all the data, and we know about that. There is some mechanisms in the back end that look that the agency is aware at all times who is really a healthy follower that has all the data that the leader also has. So let's go up a little bit and let's check back with the job ID. This is 90-112. These are jobs that are sitting in to-do and apparently nothing is going on. The job's been sitting there for quite some time now, for over a minute and a half, and it's still there. But let's go back up here and we see these failed. Which one was it? Sorry for that. I need to go back check. 90-112. What do we have? Okay, here's a failed leader job that belongs to this bigger job. The responsibility as a leader for this shard was shifted from the second one that we just killed to one of the other 2 that is healthy. By the way, we could just go ahead and bring back the 1 machine. I'm wondering if that's interesting. This is the one that didn't, yes, this had an agent. The one that didn't have an agent, where is it? This was this one. So if I bring this one back, all those jobs that were sitting there should be satisfied. Let me just do this. I'm just going to start up this one. It didn't have an agent, so the agency is still not happy. If we go here to the configuration, we will see that there is still an agent missing. This is not a good situation. If another agent goes, then your whole operation stops until you bring back an agent. So you see this guy's been missing now for about 6 minutes and 15 seconds. But we brought back the one server that had, where are we here? The one server that was registered as 0004, and that one came back. Let's go here to the shards. Is this a glitch or is this really? Right, I'm just gonna, aha, that's interesting. What happens here, what happens here? Let's go back and check with the jobs. That's actually what I wanted to show you, how those jobs get processed that were sitting there. Let's read the target again. So there's nothing in pending, there's nothing in to-do. There is nothing in failed. So all those jobs that were waiting for another server to show up have finished. I seem to have a serious issue here with my browser cache. Let's do this completely. Nope, it stays like this. It's really hard. I can't do this. I shouldn't need that either. Okay, I don't know what I'm experiencing right now. This works actually flawlessly. And if we look here, we also see all these jobs have finished. And it took, let's look at one of them that was sitting there and waiting for a server to appear. Where do we have one? Where do we have one that took a couple minutes to finish? Yeah, here's one. It was created 1624 UTC, London time, and this one job finished then actually, and started and finished because it could be quickly satisfied by shifting the responsibility as a follower for the database foo and the collection. Yeah, these are collection IDs. These are not collection names, unfortunately. This will be our bar collection because we don't have any other to this other DB server. I have some issues with my front end. I don't get this. This shouldn't look like this. And this is also not happy. And this is making me not very happy either. And I can't do anything about it. This is really strange. Okay. Apologies at this point. I also have no quick solution to this. So we leave it as is. You guys just go ahead and try it. It should work with you. Maybe I tested too much. I don't know. Whatever. Let's continue. Let's try to salvage the situation with the one missing agent. Where is it? The one that we terminated here. So this is machine 12. And let's say this one is lost forever. We are not going to be able to recover this one. The hard disk is gone. And we will mimic that by going to the one machine that I haven't used. This is C9 here. And just take this command and run it over here. Let's see that we have a clean sheet. The secret file is correct. We will just do this. If I start it like this now, the only thing it's going to do is it's going to add another DB server and another coordinator to the whole outfit. That's not what we want. We want to have another agent to recover from the situation that an agent is missing. And this can only be done by enforcing that. The reason really is that agents are ultra sensitive. We can't afford to break the agency. It's really easy to, by either not being thoughtful or maliciously, if you have the secret and you know how to communicate with the entire outfit, to break the agency. So if you go and read the Raft paper, if that's if it interests you, it's really, really interesting paper to read. It's all about how to create consensus among machines. There's also a blog post that I wrote a little while ago about our implementation of it. You will realize that Raft is really supposed to salvage any situation that came about by so-called non-Byzantine errors. Byzantine errors are effectively if you, as an agent that takes part in the agency, send wrong messages, like the lead tells you to commit some particular log message, and you go ahead and don't log it and return, I have logged it. That would be a Byzantine error. Or if you introduce an agent without any data with a new ID and vice versa. This is something that needs to be done with great care. That's why you actually have to do something here. And we're going to do that and force a start of an agent, but not without paying a lot of attention. Okay, the way this is done, as a matter of fact, let's go back and check here, the help message. If you go a little, scroll up a little bit, you see here, that's, where is it? Start an agent and enforce that. So let's go back to our command. It should still be in my, you copy it, okay. So cluster start agent, true. This is not all that we need. We need to go a step further. Let's go back and find out the ID of the missing agent. We still have the configuration here. The one agent that hasn't responded now for over 6 minutes now is this guy. We need its ID. It's easy to identify because that's the only one that is keeping, not answering, not acknowledging any commands that is coming from this leader for that period that is given here in seconds. So it's now a lot of, wait a second, it's like 12 minutes ago, not 6 minutes ago. 12 minutes ago, this thing went down and hasn't responded. Okay, let's go back here. Where is it? Yeah, that's where we want to run a new agent and empty, with empty data, with another coordinator with empty data directory and a DB server with empty data directory. Let's do that by specifying the disaster recovery ID like so. Okay, this ArangoDB starter will join the rest of these guys. It has the proper secret. We are forcing it to start an agent, and we are giving the one agent a specific additional parameter, which is agency disaster recovery. Oh, wait a second, there is a typo, important one. Here, this needs to be a point. This is passed to the agent that is to be started. I'm just gonna do this. Agents up and running. We should have some stuff going on here. Let's go back and check what the agency is telling us. We have an agent. It's joined the bunch. And where is it? It has now this new IP address. It has the old agent's ID. If you don't have the old agent ID, you cannot join. But again, it's in the agency if it's running. So the agency complete again. This leader says that it just had communicated. If we do it again, you see that these figures change a little bit. The one figure that's always going to be 0 is the figure for the leader itself. So there's no point to measuring the last acknowledgement of some command to oneself, right? So this value is always going to be just whatever, an artificial 0. Effectively, it just means that it's yourself, you're the agent. And this is, these other two are the followers, and they have acknowledged the last command a little while ago. This is 0.06 of a second. Let's go back here. The situation here recovered, the one that I didn't like. Remember all these yellowish things? But this is kind of odd. The rebalance shard job that I sent out, unfortunately, also kicked in, as it seems, because I'm seeing here 124, 214, 215. This is definitely a server that we started later. So yeah, I don't know what was going on. We still have these two on red, which makes perfect sense because this DB, this one machine that had these two instances sitting on it, we never brought back. Remember, we left C12 turned off. So that's the one where the shell is still looking like this. I'm not going to start this command. There are good chances that we are going to mess with the agency. But remember, this was the machine that went down, that you lost, the hard disk broke, whatever. The entire machine went up in flames, the data center was nuked, whatever. Okay, so this is the way you would replace a node with a fresh one. We started with 4 machines. We are back to 4 machines. We have 2 nodes at some point were sitting in there and are still failing. You can remove them. We're not going to care about right now. That's not what we wanted. We wanted to see how the whole situation salvages itself or doesn't in case of agents really needs manual intervention. If I go back to our collection here, you see 5 here is only 5 is actually the leaders are still the 1 and 2. So this is a kind of an important thing. As long as you just bring back new nodes, we don't go ahead as a software and redistribute shards as long as you don't want to. This is really kind of important. Once you've brought in new hardware, once you replaced hardware that is gone, you really have to take care of the rebalancing of the shards that are in the cluster. I'm just going to click on this again. It's working now. And it should redistribute some of the imbalances that are within the cluster. It takes a little while. It's going to do that shard by shard. And as you can see, this is how things are progressing. And see here, for example, this one got a leadership, the one that we just started earlier. Here it is also in leadership twice. And yeah, it's pretty much done. We go back to our jobs. Where did we have them? We have to look for target, the command that we had earlier. A lot has happened. There is no job in pending. There is no job in to do. You really have to be quick to see them. Or you have to have a situation like earlier where there wasn't any servers to satisfy the replication factor of 3. You have a lot, no jobs in failed, by the way. Down here, nothing failed. Well, there wasn't a situation that actually really was so tricky that jobs would fail. Jobs actually shouldn't fail. When would a job fail? For example, let's say one server that was a leader to a shard goes down. It's rebooted or whatever, had a power outage or something. While the failed leader job hasn't really started because of whatever reason, the server comes back. That's when the job would immediately be put in failed because the server that was gone, was assumed gone, is back and can actually do the serving. Before you start shifting around terabytes of data, you'd rather go back to the old leader and hope that the situation is fine. So that's when the job would end up in failed. Or say you had a move shard job where you were moving a shard from one DB server to another one, and during that period, the DB server that you were pushing the data to went down. That's when the job would fail, for example, because the DB server is gone. Everything that has happened in the backend by the supervisions was successful during the period, during all this playing around with the servers that we did. There's a lot of jobs that accumulated here. I'm just scrolling up. Don't try to read anything. I'm just trying to show you that there's a lot of jobs out there. In case you should find it odd that some jobs have like these handy and somehow simple numbers or smaller numbers, while some jobs have these huge numbers here. That's because every DB server, every coordinator, when they start operation, go to the agency and get a block of numbers to use as unique IDs. Once they run out of those blocks, they go back to the agency and acquire a new block of numbers. So how did this work? So whatever happened here, whoever was responsible for starting this job did it with a block that was acquired not as the first server, but as a second or third server. That's the reason why some of these really have these odd numbers, and some of them have these smaller numbers, although we just started the cluster. Okay, so there's nothing odd or strange about that. It's just who came first got which block of numbers. And as you can see, everybody's getting about 10,000 integers and working with those until they are run out of them. And then we acquire a new set of numbers. It's really just to make sure that you don't have twice the same job ID, twice the same sharp ID, and vice versa. Okay, so that's what we saw here. How we recovered from that. Let me look through what I wanted to do next. So we have killed a server where only a DB server and a coordinator were located. We brought that back. We killed a server that lost its data. Apparently, the server was completely lost. We brought in a new server, brought in a new agent to participate in the raft in the agency, and that's what we did so far. Let's do something else. Let's have a look at very quickly at this C9, the one machine that we started last. Where is it? What is this? That's interesting. This is C9. Haven't seen this error message, cannot really comment to that. What I wanted to do was, I wanted to go there. Let's just go there. And look at the version of the ArangoDB binary. This one is running version 3.3.8. And as you can, we can also check, by the way, this over the API 8.5, whatever. Let's just take, this didn't, yes, this does have an agent. We just started one API agency version, API version, actually, that's all I wanted. We need this thing again. Authorization Vera JWT again 256. The secret was ABC. ISS now running. Oops, I have some really odd keyboard here. ArangoDB minus C server ID is set up. Like that. Oops. So this is 3.3.8 Community Edition. Let's go to one of the servers that are still running that we haven't killed. Anyone except C12 will do. And you see this is 3.3.9. This is not something you should do. I just did it for one reason alone. I wanted to show you how you do a rolling upgrade on the last machine in this case. A rolling upgrade technically can be done manually by just installing ArangoDB, a new version of it. I have it already sitting here. So let's say dpkg, should be root for that. dpkg minus ArangoDB. And then just restarting the individual services. So let's just say PS. Let's find out which one is the agent, for example. How do I find this out? Port is 8531. Yeah, that's a lot. This is the guy. This is the one that has the database directory sitting there. So let's just kill it. Kill, and do it nicely with -15. What will happen is the starter will monitor that it's gone and restart it. So if I go back here, it should have reappeared in the meantime. It's sitting down here. Let's go back and check its version by asking this machine, C9, the agent's port. and it's running 3.3.9. So you can go ahead and kill individual services. The starter will automatically restart them. And through this process, every machine is upgraded to a new version. Let's do that with the next one. Where is one? TS. Let's do that with one with a coordinator, for example. Go also to the UI of this machine. C98529. Yeah, root password. Sorry, root. I don't think you can see anything. I'm going to blow up the font a little bit. See, it still says 338, and it's giving you this wink of upgrading. Let's just kill this process. Let's be a little brutal about this. I'm just going to -9 this. This is a coordinator. Don't do it at home. It doesn't have really important data locally. It's supposed to be working as a, it should be already there. Just going to click. No, it's still giving me the wrong version. Reloading gives me the new version, 3.3.9, and so on. You get the message. But there is a new version of the starter out there that is shipped with 3.3.9, and as far as I remember, with 3.2.14, but don't nail me on that, that does the rolling upgrade for you. You just have to tell it to do the rolling upgrade, and it will cycle through all these services, and after upgrading, it will restart them without the supervision taking action just because the DB server has gone for a couple of seconds. Okay, we did the rolling upgrade, and I'm kind of running out of time. It's we've got only 9 minutes left. Are there questions out there? I'm looking at the chat window if anybody cares to ask. Okay, something's going on. No, nothing's going on. Chat window is empty. Fine. Is anybody still listening? I really hope so. You talked a bit about the active failover. What's in specific? So the question is, can you talk a little a bit about the active failover? Okay, so let me just say very general stuff about the active failover. It is different from the cluster in the sense that you don't have the sharding part. That means that all collections are effectively just replicated. There is no sharding going on. And the only thing that you can do as a flexibility still with the active failover is that you can have a resilient agency. So you can have an agency that has, if you started with the starter can start an active failover setup. Then it will start with 3 agents, I think, as a default parameter, so that your agency is resilient. If one machine goes down, it's going to only affect one agent, right? And thus the agency can still keep on operating, working for you. And so effectively of the 3 machines, only 2 of them are doing actually DB serving, and there is 3 agents sitting on them. Apart from that, the active failover also detects if the leader goes, and the follower will take over, and vice versa. But it's really, everything that I said just now about the jobs, about the way failures are handled, and so on, particularly about the agency, is exactly the same as in the cluster. The only difference is really that you don't have the shard. Okay. Okay, then I think it's been quite some information. If I start the next chapter, it would be way over the time. So the deployments, so what I'm going to do is the following. We have dealt with, yeah, actually, you know what? Let me show you something to maybe clarify a couple of things a little bit. Let's go back to the agency dump that we had earlier. Where did we create it? Was it here? No. Was it here? No. Was it here? I think we were close that window. Ah, it's probably whatever. Let's just, we have somewhere here this sitting. Okay, the current leading agent is, I think, C10. API agency config. Yeah, it's C10. Okay, let's do this. Let's go ahead and try to understand a little bit this whole sharding business. Let's read from the agency. Arango, plan, collections, foo. Now, what did I miss? Curl, blah, blah. This is the minus D. Sorry, that was just a type. Okay. This is all the collections. These are all the collections that are sitting in the foo database. See, what I did was, this is like the default key. Everything that is in the agency that is that belongs to the cluster is sitting in the Arango key here. What is planned is going to be in the plan. This is the only place where any external changes to the cluster, that is creating new collections, making new databases, and so on, we'll always write into the plan, and the DB servers will realize those changes and accordingly react. We have the collections are sitting in databases, this database foo. Let's scroll up a little. Sorry. Okay, here's the collection that we created, remember? The one that had 9 shards, 1, 2, 3, 4, my goodness, 4, 5, 6, 7, 8, and 9, and so on, and 3 replica of every shard. These are the DB servers that are responsible. We have the 33, FC, D4, FC, 33, D0, and so on. This is the representation, the JSON representation in the agency of the picture that you see on the nodes page. Okay, what else can you see? If you go a little higher up, you actually see, oh, sorry, a little further down, we were in the other collection. You will find the name somewhere down here. This is the name of the collection. Yes, the collection's name was bar. There is only a single field that is indexed, the key. This is the field that is always indexed. It's a primary key and vice versa. Now, if you actually go to these DB servers, we will find, let's see, so FC03, let's find this guy in the supervision. FC03. Let's find this guy in Arango supervision. What is missed? What is now? Again, the typo, sorry. FC, here it is. This is the DB server on 11. Let's actually go there. Let's say Rangosh, TCP. No, actually, let's do it like this. Curl, we already have everything here sitting. We're not going to go to the agency. We're going to the DB server, and we're going to say API collection. And that should be it. Okay, I have a list of collections on this DB server. And you probably won't be surprised to find this particular shard somewhere up there in the agency as part of the big JSON where you see all the shards and the responsibilities of those. So what I wanted to show you effectively is that what a cluster does in ArangoDB in an ArangoDB cluster, and what the DB server does, what the cluster, the coordinators do, and so on, is actually not so magical. Coordinators will get a request for a document. They will look in their the way they would find a document on a particular shard based on its shard key, right? And then go and get that document from that DB server. The DB server will have a real collection locally that is just a shard to the cluster collection, out of which it will just deliver the document. So just to take a little bit of this magic behind it, that it looks more familiar to you. If you ever look on the DB server, this is really not something that you should manipulate under any circumstances, because the cluster will not be able to serve documents anymore. You will effectively break everything if you start playing around with things on the low level. But this was supposed to show you how these things are connected. What is written in the agency is something that both coordinators and DB servers see. They see how the sharding of documents in a collection is done, how they're distributed here and there. And that's how things are gotten back when you want to access them, document basis or through AQL, and then deliver them to the front of the coordinators, compile everything, and give you the answer to your query. Yeah, so I think with that, we've pretty much seen the anatomy of the cluster in depth, with how things are set up, how you recover from failures, troubleshoot things, and vice versa. And for the next session, then we will do Kubernetes deployments. We have a really nice new deployment framework for deploying Kubernetes clusters. It's so simple, and I think we're pretty much at the spearhead of what people are doing right now with persistent volumes and so on. It turned out to be quite tricky. And then we also will be looking at enterprise features like DC to DC, where you can set up 2 clusters and do a asynchronous replication between the 2. There is already one customer out there that's using it, and we are very thrilled. It's an exciting new feature that we offer, and yeah, would love to show off a little bit.